Hi everybody. We are going to do some section 1-6 today. So section 1-6 in geometry is all about polygons. We're going to identify them, we're going to name them, we're going to find perimeter, circumference, and area. There's a little bit of formula work here, and we're looking at two-dimensional figures. We've got some circles in there as well, even though we're going to find out in a second, a circle is not technically a polygon. A polygon is any closed figure formed by segments. So you know we've been talking about segments, lines, and rays. Well, each side has to be a segment. We know that segments are straight. There's no curves involved. Sides with common endpoints are non-collinear. So you can't have a polygon that it's two sides, but it looks like one straight line. They have to be non-collinear. And each side intersects only at the endpoints. So you couldn't have something weird like that. We couldn't have something weird like that, because that's got a curve, not a segment. We couldn't have something like that, because they intersect at a point other than the endpoints. I put symbol, but really I want to say how they're named. So named by all the letters of the vertices in order. So notice this example up above, polygon G, H, J, K, L, M. I've got to use all 6 vertices to name those. Vertices is plural for vertex, so we've got a bunch of angles, 6 different angles, so we're using those vertex of each angle to name them. Notice that we also call the sides as a segment. Notice that this side GH right here has got a segment symbol above it. It's not just GH, it's not a line GH, it's not a ray GH, it's a segment GH. So an example could be triangle ABC. When we name them by all the letters of the vertices in order, when I say in order, I don't mean alphabetical order. I mean order around the figure, around the polygon. So I could call this triangle CBA. As long as I don't jump around on that 6-sided figure in the example that was on your notes, I couldn't call it polygon MHKLJG, because I'm jumping all around from point to point. I need to go around the outside of the figure without skipping. This is also a polygon, and it looks a little weird, but this is a polygon as well, and I could name it like LMNOP. So it would be a 5-sided figure. We're going to talk in just a second about concave and convex. That is a polygon. It just happens to be a concave polygon. So concave, you might know this from science class. I think you talk about concave and convex with lenses. In concave, a vertex lies in the interior. It goes back inside itself. So this guy right here would be concave, because this point comes back to the inside instead of going out that way. So concave. And then convex, no vertices are interior points, like this pentagon ABCDE. If you don't remember the different sides, like a pentagon is 5-sided, we're going to talk about that. I've got a little table on your notes for you. So the other important thing that we need to mention is regular polygons. This is a really important term, regular, because it tells you something important about angles and sides. In a regular polygon, all sides and all angles, I'm going to put all sides and all angles, are congruent. All sides, all angles are congruent. And again, feel free to abbreviate. You could use congruent symbol instead. But notice in my concave polygon on the top example, all the sides are congruent. Everybody sees the congruent dashes, right? So all those sides are congruent, but are all of my angles congruent? I've got this pair of congruent single arced, and then I've got another pair of double arced, and then I have this one that doesn't have any mark, and then I have this one that's that interior point that doesn't have any mark. So this is concave, and it is not regular. This pentagon ABCDE, however, notice all the sides are congruent. Side AB is congruent to BC, which is congruent to CD, which is congruent to DE, which is congruent to EA. All those congruent dashes on there. And what do you notice about all of our angles? Angle A, B, C, D, and E, also all congruent. They all have that congruent arc. So we would say that this is a regular pentagon named ABCDE. Perimeter, hopefully you know perimeter, is the sum of the sides of a polygon. And of course, what does sum tell you? What mathematical operation will you use? We're going to add, right? There's formulas you can use for perimeter, but who needs them? If you can just add up all the sides, you're good to go. Circumference, what kind of shape are we dealing with for a circumference? We've got ourselves a circle. Basically, circumference is the perimeter of a circle. Perimeter of a circle. I like that definition better because then you understand that perimeter is the distance around the outside. It's harder to measure because it's curved. We don't have straight segments like in a polygon. So we've got a formula for that one in just a second. You probably already know it. And area is a two-dimensional idea. It's the number of square units needed to cover a surface. The number of square units needed to cover a surface. How many little blocks will fit inside, side by side? If you look at the floor of the room, every one of these tiles is 1 foot squared, 1 foot by 1 foot. So we could find out how many square feet fit in the room by counting up all the tiles or by using the area formula. So let's talk about these formulas. I've got 4 of them for you: triangle, square, rectangle, and circle. So triangle, oh, I thought I had something in there. First of all, for perimeter, this is going to be perimeter, this top line. I'm going to write this across these first 3. Perimeter equals the sum of all sides. Stop before you hit the circle, because the circle's got a formula. The circle is going to be pi times the diameter, or circumference equals 2 times pi times the radius. Everybody's familiar with radius and diameter? Diameter is the whole way across. Radius is halfway across the circle, so always going to the center. So here's our perimeters. Next line down is going to be our areas. So there's formulas for the areas, and hopefully you know them. The area of a triangle is equal to, I write it this way, base times height divided by 2. Some people like 1/2 times the base times the height. Whatever works best for you. It's half of the base times the height. And these two guys together, let me do this. I'm going to bunch those two together, the squares and the rectangles, because I'm going to use the same formula. Area equals base times height. It just so happens, excuse me, that the base and the height are the same value in a square. So you just square the number, but you're still doing base times the height. I like to keep it as simple as possible. I don't want to memorize 3 formulas when one will serve the purpose for all of them. And another thing for triangles and squares, some people learn those as length times width. Switch yourself over to base times height at this point. I'm always going to use base times height, or base times height divided by 2. And last but not least, our area of a circle is pi times the radius squared. Pi r squared. Okay to everybody? So once we got the formulas, we end up with word problems or just given problems. I'm going to skip this practice problem because I just want to keep going and run through our special names for polygons. So down the number of sides column, start with 3, 4, 5, go all the way to 10, 9, 10, 12, and then put n. 3 to 10, a 12, and an n. That rhymes. Actually, I do know the name for an 11, but so a 3-sided figure, we all know that, right? That's a triangle. 4-sided figure, we're going to be as generic as possible here. There's a lot of different things. You could tell me it's a square or a rectangle. You could tell me that it's a parallelogram. But in general, a 4-sided figure is called a quadrilateral. Quad means 4. We know a 5-sided figure is a pentagon. We know a 6-sided figure. I always remember the X's go together. Hexagon is a 6-sided figure, X and X. A 7-sided figure is a hept, H-E-P-T-agon. Heptagon, don't get that confused with a hexagon. An 8-sided figure, like an octopus with 8 legs, is an octagon. 9-sided figure, I like this word. It kind of just rolls off the tongue. 9-sided figure is a nonagon. 9 and non. N-O-N-A, gon. 10-sided figure, like 10 years, would be a decagon, a decade, a decagon. D-E-C-A-gon. 12-sided figure, this is another good one. Rolls off the tongue nicely. 12-sided figure is a dodecagon. So take your 10-sided figure and add a do in the beginning, dodecagon. And then sometimes we're just using generic things. I would say I've got an n-sided figure. So I would call that an n-gon. I know it seems a little strange, but I mean, I could say how many degrees are in an n-gon, and you wouldn't be able to give me a specific answer, but you'd be able to give me a formula with n in it. So example 2 right here says to name each polygon by its number of sides, classified as concave or convex, regular or irregular. Here's the problem with this one. I really, if I was smart, would have marked this guy up. So go ahead and mark it up. Give yourself 6 congruent sides. Give yourself 6 congruent angles. Now we can answer this question. So first of all, we said how many sides were there? And so that makes it a hexagon, 6-sided figure. Is it convex or concave? Concave means it's got a point that's going inside, right? Like you're walking into a cave. There are no interior points, so this is a convex hexagon. It says to tell us if it's regular or not regular, irregular. Well, regular means all sides and all angles. Remember that assumptions thing. We can't assume unless they're all marked, and hopefully you marked them all, which means that this guy is regular. All 6 sides are congruent. All 6 angles are congruent. Letter B is an interesting one. We're going to name it. I'm not going to do any extra marking. So let's name it by its number of sides. How many sides does this figure have? Looks like 12 to me. Everybody agree? So 12-sided figure, dodecagon. Had a nice ring to it. You really should say it. Is this dodecagon concave or convex? Well, look at this point, this point, this point, and this point. These guys are interior. They're inside or they cave in on themselves. So this is a concave dodecagon. And there is no marking that says that all the sides are congruent. And there definitely is no possible way all the angles could be congruent because these angles right here are much larger than these guys that look like they're 90s. So it's definitely an irregular concave dodecagon. I'm going to have some problems for like that in the homework, so I just wanted to make sure you could see the difference between convex and concave, and you know what you're looking for regular or irregular. The naming part you've been doing for years, I know. And we've got ourselves an XY coordinate plane. I think this will be the last example because I think the other ones you can handle. But we do need to talk about this. It says to draw triangle PQR. So the first thing I'm going to ask you to do is draw triangle PQR. There is graph paper on the side table over by the red calendar algebra bulletin board. Feel free to grab graph paper. I think I'm going to give you 2 or 3 for the homework. If you don't want to, you certainly don't have to, but we're going to draw on some stuff that we've done already this year. So we're going to draw a triangle PQR with those given coordinates, and then we're going to determine the area and the perimeter. So we've got an A equals and a P equals. Before you even worry about the area and the perimeter, I'm going to sketch those points. So -1, 3, -3, -1. I'm going to label it P, Q, and 1, 2, 3, 4, -1, and R. Everybody like my placement of my points? Make sure you label them. You might even want to put the ordered pairs on there because it'll make it a little bit easier when we go to do the rest of the work. Now, here's the thing. If I'm going to find the perimeter, I always start with perimeter. I don't know why. You don't have to. But if I'm going to do the perimeter, what is perimeter again? Perimeter is the sum of the sides, right? Sum of, do we know the lengths of the sides? I see one that I could eyeball pretty easily that I know the length of. It's that horizontal line. Anytime you've got a horizontal or a vertical, you can count them. So this segment QR is 1, 2, 3, 4, 5, 6, 7. I got one side. I do not, however, know the length of PQ or PR. So how do I find the length of PQ and PR? They're not horizontal or vertical. They're not nice and neat on the grid marks. I can't just count them and get 7 like I did for segment QR. I'm going to have to do a little Pythag, or everybody's favorite, distance formula. Since it's on a graph, if you want to draw on the triangle and do Pythag, so for example, if I'm going to do PQ, I'm going to draw this in. I would drop that. I would go this way for my right triangle. And then this is going to be my x value, PQ. I know that the height is 1, 2, 3, 4, and I know that this is 2. So to find PQ, I could do 4 squared plus 2 squared equals c squared. Remember Pythag. Whoops. Let me write it right. Then you'll remember it. A squared plus b squared equals c squared. A and b are the legs. C is always the hypotenuse. So that means I'm going to get a 16 plus 4 equals c squared. So c squared equals, actually, let me fix that. C squared equals 20. So c is approximately, we're going to have to go to decimals. A few people I noticed on the last quiz went to simplified radicals, which suggests to me that your calculator did that work for you. Please make sure you know how to turn that into a decimal. The square root of 20 is approximately 4.5. I'm going to go to the nearest tenth. So that's the length of PQ, 4.5. 4.5. I'm going to circle it so I don't lose it. If I want to find the length of PR, that means I'm going to have to either do Pythag or the distance formula. I'll do the distance formula this time, just so that you can pick which way or switch back and forth or whatever, but I want to show both ways. So I'm going to set PQ aside over here so that I could do distance formula. So I'm going to do PR. I always label what side I'm finding, because if I don't label it, sometimes I forget what I've got or I can't figure out what I've already done. So distance equals x2 minus x1 squared, y2 minus y1 squared, and I could label this x and y 1 and 1, x and y 2 and 2. It doesn't matter which one is which, pick one. So that means I would have a 4 minus -1. I'm going to choom that and make it 4 plus 1. I would have a -1 minus 3. So that means I'm going to be taking the square root of 25 plus 16. So distance is the square. Am I going too fast? 4 squared, so that's a 5. 4 plus 1 is 5. Squared is 25. Negative 4 squared is positive 16. So 25 plus 16 gives me, what is that, a 41? And the square root of 41 in decimal form is going to be a 6.4. So now I know this guy's 6.4. I did the distance formula. I know that PQ is 4.5. I did Pythag. You can do them any way you want. So my perimeter is going to be 7 plus 4.5 plus 6.4. Usually the perimeter is the hardest part. Area is a little bit easier, especially in this problem. So that gives me a perimeter of 17.9. I don't have any units. I could say units, I guess, but area, we've got and this is a lot of work. I do recognize that. And it's a lot of bits and pieces that you have to keep track of. Area, I've got myself a triangle, right? So the formula for the area of a triangle, look back if you need to, is base times height divided by 2. Well, the base is typically the bottom. You could turn your paper around and make a new bottom, but the height is how far it is perpendicular from the base to the highest point. Well, this is my base that is 7, because I like to use a vertical line if I can, which means that this is my height right here. We actually found that height when we did that first Pythag. That's 4. So my area is going to be a base of 7 times a height of 4 all over 2. For that area height, I can just count it because it is a vertical line. So my area is going to equal 28 divided by 2, or 14 square units. So there is a little bit of oldies but goodies with the distance formula or Pythag. And I'm not sure if you remember using the area formulas before, but here they are, and here's what we got. So I'm not sure if I have your assignment right on here. Let me fix this. We're going to skip this. Do the best you can on the word problems. This is not right. Don't write this down. The correct answer is 14 to 26 all. 14 to 26 all on page 61 and 62. All right. Have a great day. Use this time wisely to get some work done. Ask questions when I get back, and we'll be good. Don't worry about any of this other stuff. I know. I didn't give you any online quizzes. I will, though. Have a great day. We'll see you guys next time.